What if I say x is the number of CDs, and I say the amount of money I spend is 12 times that, and I am comparing it to $60. And which one of those two is going to be bigger? 12x or 60? 60. Could it be equal to 60?
Yes.
Yeah. Okay. So that would be an example of an inequality you could write. Can you buy 6 CDs?
No.
How do you know?
Because 60.
Because, Maddie?
Because 12 times 6 is not 60.
Okay, well, it doesn't necessarily have to be equal to 60.
Well, yeah, but if you're buying each one for $12, it doesn't make sense. Like, it's too much. Too much money.
Too much more.
If you plug in 6, you get 6 times 12 is 72. 72 is not less than or equal to 60, so no, you can't afford 6 CDs. If I came up with, say, a variable that represented any height you could be in the United States, you know, I say, oh, how about h is equal to the height at any point in the US. I want to write an inequality that relates this height h and some maybe an important piece of information from our story problem here, from our statement. Is there any particular height that we will always be either above or below, according to our statement here? Above what? The lowest recorded is what? Death Valley. Negative 282 feet. So if the lowest is negative 282, will we ever get below negative 282? No. So that means this is the minimum value, the smallest value. Or h is always, how does h always compare to negative 282? How does h and this number, how do these two things compare? What is it?
Greater than or equal to.
Our height is always bigger than or equal to negative 282 feet. Where is it equal to negative 282 feet?
Below. Oh, Death Valley.
In Death Valley. So we could be at negative 282, or we can be anywhere else in the United States, which is got to be bigger than that. Okay. Do we remember how to graph inequalities?
No.
Lily, how do you graph an inequality?
So you point a number line around negative 282.
Okay.
Like X. And then you draw the circle thing.
Mm-hmm.
And then you draw an arrow to the right.
Why to the right?
Because that is greater than 0.
That's where all the numbers that are bigger than negative 282 reside. And then do I leave this, is this done? Okay, why do I need to fill in the circle?
It has the line.
Oh, because it's equal. Because it's equal.
Bubble stamp.
Because it's already equal. Graphing an inequality, we put a point at our value that we're either bigger than or less than. If it's or equal, we'll fill that bubble in. And then we'll put an arrow in the direction of where all the possible values are. H is any number that's bigger than negative 282. So I'm going to put an arrow in the direction of every number that's bigger than this number, and where any numbers are always bigger to the right on a number line. Notice this is like the minimum amount of information I would need in a number line. If you wanted, you could fill it up with some other points. You could say like negative 281, negative 280. You keep going. You could go this way with some numbers if you wanted. 285, and you could fill in some more if you wanted, but we really only need the number line, the point where we're at, circle, either filled or not, and then the arrow pointing in the direction. In these three below, I'm going to make up some number lines, and you're going to write an inequality for me. So here's a number line. I'll even fill in all these values here. Notice how, I guess before I go much farther, Notice how I drew mine above the number line? You don't have to do this. If you want to draw it right on your number line, that's fine. But then you get things like this. And I don't know which way you drew an arrow. So I always draw mine above the number line so I know where the arrow's going and what you see. So just keep that in mind. So I'm going to make up a graph here and you're going to tell me what the inequality should be. Okay. What should be the inequality that goes along with this graph? Sure, pick whatever letter you want. Z. Okay, we'll go with A. Well, the first one will go there. Okay. So if we're going to choose the variable A, what should the inequality be?
A is greater than
Is it or equal to?
No,
It's not filled in.
It's not filled in. So it's strictly bigger than 2. Okay, let's do another one.
Okay. Oh. J. Letter J.
Okay. We'll roll with J this time. J and this number line. What should the inequality for this number line be?
It's less than or equal to.
Okay, stop. One at a time and hand raising it. So,
J is less than or equal to.
perfect. Okay. And since you got it right, we want to go. What letter do you want to go with this time?
Oh, I wanna go. Oh my gosh, why? No, wait.
Too late. So why? Okay, our last one. Lily, what's the last one? The second part of today is once we can graph these, well, now we're going to start trying to solve inequalities. For solving inequalities, we're going to treat the inequality just like an equal sign. We're going to solve it exactly the same way. Just pretend it's an equal sign and let it roll. We'll see tomorrow. Tomorrow we'll see situations where we might have to do some minor adjustments, but in the grand scheme of things, they're basically the same thing. So if I need to solve this, and in yours the x has been cut off because they printed out a whole bunch of paper. You missed the x. Should be x minus 9 is less than or equal to 3. So if I solve this, I'm going to solve it just as though that was an equal sign. So what would I do if that was an equal sign to solve this?
Add 9.
So we add 9. X, same inequality, less than or equal to 12. Solve the inequality. Here it's solved. Let's graph our solution so we can see visually where all the numbers are. If you want, you can do what I do, which is the minimalist number line, which is find what value you need. Oh, there's 12. We'll just look at the part of the number line that has 12 right in the middle. And my fill-in bubble going to the left. Okay. It's amazing how when you're drawing your number lines by hand, that you can just find the part of the number line that you really want to see. I care about 12, I'll put 12 right there. Same game. let's add 3.8. M less than 3.8. Excuse me. Negative 1 plus 3.8 is 2.8. And what's amazing is that you can actually probably find the spot on the number line that's at 2.8, namely this one. Look at that. We found where 2.8 is on the number line. It's kind of hard to find it. And then we'll graph this. Open circle, less than, goes to the left. Graph. Oh. Okay. You have 3 more examples here to complete on your own in the next, say, 2 minutes. Please solve and graph them. Okay, we'll do the 2 easier ones right away. The 2 bottom ones, we just subtract, say, 5.5, you get y bigger than 0.5. Find 0.5 on the number line. Look at that, there it is. Y is bigger than 0.5. It's not equal to, so I have an open circle. 0.5. Subtract 7. B less than -4. Find -4. Look, there it is. Less than goes to the left. The last one is the trick question that 75% of you didn't have correct the first time. If we add 1/2 to both sides,
Yeah, see, this is my student council got wrong.
you get -1/2 is bigger than or equal to m. Sure. -0.5 is bigger than or equal to m. Sure. Well, -1 plus 1/2 is still negative. This part, most of you still did all right. Okay. How do we graph this? Let's find where -1/2 is. Sure, right about there. What does this inequality say? It says -1/2 is bigger than or equal to m. What's the reverse of that? What if we start on the right? M is less than or equal to -1/2. The number that's bigger is the -1/2. Any number you pick has got to be less than that. So where should your graph be pointed towards? The left. Because m is less than -1/2. Is the correct graph of this situation. Now, one way you could have avoided this pitfall would be to say, well, if I have the m on the right side, how about I rewrite it so m's on the left side? So it looks like all the other examples I just did. If I switch these around, say m, -1/2, and then which way does the sign need to still be pointing if I'm going to keep this the same? Toward the -1/2. So if you wanted, you could rewrite this so the m's on the left side, so it looks just like all these other ones, so that we can graph it appropriately without actually having to use your brain too much, without having to think about what this actually means.
So if you have the variable.
All right. Last but not least, as I said, you're going to see a lot of story problems. Inequalities represent life a lot more than equations tend to, so we're going to see a lot more story problems as we kind of go through. You'll notice that we did way back in chapter 1, we rewrote from sentences expressions, and I even was so kind as to take a table from back then, and just as a refresher, give you like symbols, their definition here, and then kind of some keywords that we saw from sentences to help you like write some inequalities out. Since we're going to be doing this, you may want to refer to this table. This was way back in chapter 1. In our situation here, we're shopping for bicycles. The type I want costs at least $185. Right now, I've saved $97. Find the possible amounts of money I'm going to need to save in order to buy some bicycle that I love. What are the important pieces? Well, definitely, we know that it costs at least $185. What does at least correspond to? What kind of sign? If you didn't really know, you could look over here. The at least is a greater than or equal to symbol. Okay. It's at least 185, and then what's at least 185? Well, the amount of money I need to save, right? Well, what's the amount of money I need to save? This is over on this side should be the money I need to save or I've already saved. Well, I've already saved 97, and I need to save how much more money? Do I know that? Sure, we'll go with money. M for money. To save. Okay. So if I made this inequality, I take the money I still need to save, plus the 97 I already have, and if that is bigger than or equal to 185, then I should be able to buy a bike. As long as it's bigger than or equal to 185, then a bike is within my reach. And as some of you did, then you went ahead and solved this inequality. So how much money at least do I need to save? Subtract 97. If the money I save is bigger than or equal to $88, then I should be able to buy a bike in this situation, some bike that I like. The more I save, maybe I'll buy a better bike that I like, but I'll at least get one that I kind of like if I get $88 more. And just for kicks, how would I graph this situation? How to represent this? Let's find $88.
With a solid.
And then salad says 1.25.
Oh, this will be.
This represents I have all the money that any money that if I were to fall on this line, starting at this point and going to the right, if I happen to be anywhere in here, then I have enough money to buy my bike.